Good evening.
I see.
This is my minor project, and this is only for you guys. I don't matter in the record. And okay, so over here we see that the time is around 15:04, that is 3 o'clock in the afternoon. So all the lights are off. Okay. So now if I change the time to somewhere beyond 6 o'clock, okay, that means let's say 2000 hours. So here we see that all the lights are coming on. Now let's assume that in some place in the city that the traffic conditions have gone down. Okay. So here we have got an IR sensor. So what happens is when the IR sensor gets the logic 1 by an IR receiver, so we see that the lights are turning on. Lights coming on back again when the traffic is there. Lights turning off when the traffic is going down. Okay. Now, let's say the time goes up. So over the period of time, let's say we go to 2300 hours and 2300 hours. We see that the lights have been off. Let's assume that this is the center post and we've got roads coming from both these places. So alternatively speaking, we are switching off the lights. Now, similarly speaking, when we go beyond at around 2 o'clock in the night, let's say around 2 o'clock, so even more amount of lights are bringing down more number of lights. So reduce the power consumption substantially to a lesser amount. Okay, let me explain this circuit. Sorry. Let's assume that now it's the daytime and 7 o'clock in the morning. So all lights are. Okay. Fine. Now, let us assume that another condition, that it's a cloudy condition on some of the rainy days, and okay, there might be a problem on this because I'm not using industrial LDRs, so it will blink. See this? Okay. Yeah. So the LDRs work. The LDR is actually blinking. It's not an industrial LDR. That is getting light from air, so it gets confused, and you have to put the wire along outside in dark position. Okay. Now I'll explain the circuit. Here we've got an 8052 microcontroller, and this is a 1307 RTC. This is an LCD which displays time as what is the current time. These are the three switches which are entirely designed for only this circuit, where we can change the time over a periodic basis. This is a 12012 transformer reducing to 20 volts AC to a 12 volt AC. Here we've got a center tap rectifier which reduces or rectifies the 12 volt AC generated by this to a 12 volt DC. This is a 7805 which gives me a constant 5 volts of output for the biasing of the microcontroller. This microcontroller is connected with these ports to the LCD, and below the circuit, which obviously you cannot see right now, the relays are connected. Now how am I working on the sensors? This is an ST Microelectronics LM324 IC, which is it's a quad amplifier, so we are having the sensors connected to this, and according to the variable resistor settings that we have, we get a logic 1 for the sensor, or logic 0 as the sensors work, to the microcontroller. Now, according to that logic, we see whether it is a night condition or traffic condition, and then the microcontroller, according to its program, drives the relay IC. Now, the relay IC is basically it's a high current dimension pair. So what happens is, as I calculated according to the testing which I was doing yesterday, the current that is available, that it is pulling up, it is around 23.5 milliamperes to drive these relays. Now, these relays are working on a 12 volt standard supply. Thereafter, they drive, they have given a 220 volt AC supply, which is then relayed back to these bulbs. According to the logic that is generated by the microcontroller, then pull up from the relay IC, and then these relay ICs be pulling up these relays to light the bulbs. This is a very simple circuit, however, the amount of energy that we are saving is very large. Assuming that there are about 200 kilometers of road in a city, I will be saving around 64,000 rupees of electricity every day. That is like implementing this project in a city of 200 kilometers. We will be investing on 27 lakhs, and in 42 days we will be getting the whole money back. Now, the implementation of the project is zero investment, and as a matter of fact, there will be no implementation charges or installation charges. There is no taking required, nothing required. Everything is there in one board. And okay, apart from that, it's a very simple code. It can be improvised. We can even bring in calendars according to the RTC 1307. This is a battery which gives regular impulses, regular supply to the RTC real-time clock 1307 from Dallas semiconductors. to get the calendar working every now and then. I mean, and the backup of the battery lasts for about 10 years. That way, I mean, for 10 years there is no maintenance. The improvisation on the circuit comes from the fact that we are not using industrial relays and we are not using industrial LDRs. So when we go into a practical implementation from the industry point of view, we will be changing these components. Every PCB, this whole PCB costs around 500 rupees, including all things, the LCD, the microcontroller, the programming, the processor, everything costs around 500 rupees. So that's what it is. It's a simple logic, very simple idea, fun working on, and so that's it. I mean, entirely for my parents. I had the idea, I engineered it, and this is what comes out. Thank you very much. So I was saying about the engineer side. My dad gave me this idea about 1.5 years back. I was in the process of completion of a course at that time. And since then I had this itch inside me that although this project seems quite simple, but the implementation and the market realization and the market research was resulting in a quantum saving of energy, a quantum reduction in the CO2 emissions. So, and yeah, so it was fun working on the circuit. The biggest attractive part of the circuit, although might not be true for everybody, is that the wires. I mean, the wires being visible is the most attractive part for me, although it might not be the thing for everybody else. Once we get done with the PC, we have the whole PCB being designed on a printed circuit board, where all wiring and everything goes internally. So that would reduce the size of the circuit. We can work on this bigger PCB because everything will come into the same PCB, and that would become an attractive thing from the governmental point of view. And plus, I think we need such circuits. And I would seriously appreciate, request, whatever I might be spelling sort of words and injections over there. Such ideas need to be implemented by engineers, and I guess this is what it is. So, thank you very much. I had a nice time working on the project, and thanks to all my parents.